Okay, so this is the first review of the supporting information, the anatomy and histology of the respiratory tract. Remember that you have two different ways of dividing the respiratory tract. There's a conducting portion, and this is the part that just physically carries the air in and out with pulmonary ventilation. And this includes the nasal cavity, the pharynx, the larynx, the trachea, and the bronchial tree through to the terminal bronchioles. And remember, the bronchial tree is contained within the lungs. So if we do these in order, the external nares are the nostrils, and they open into the outer chamber of the nasal cavity, which is the vestibule. And then behind the vestibule is the nasal cavity proper. Leaving the nasal cavity, the openings from the nasal cavity to the nasopharynx are called the internal nares, or the choanae. Don't get choanae confused with conchi. The nasal cavity is divided in the middle with the nasal septum, dividing it into the right and left sides of the nasal cavity. The lateral wall on each side of the nasal cavity is folded into the nasal conchi. The conchi are the folds. The little tunnels of air created by those folds are the meatuses. So the meatuses are so narrow that the air, every bit of the air, is brought into close contact with a mucus that covers the surface of the nasal cavity, and that traps the largest of the dust particles. The division line between the upper and lower respiratory tracts is about at the level of the larynx. If you're above the larynx, you're in the pharynx or nasal cavity, that's upper respiratory tract. The lower respiratory tract begins with the larynx, continues into the trachea, the primary bronchi, and then into the lungs. For the most part, the epithelium that lines the respiratory tract is a ciliated, pseudostratified columnar epithelium. Floating over the top of the cilia will be mucus. Mucus traps the particles. The cilia move the mucus, and they're going to move it towards the throat. If you're in the upper respiratory tract, then you're moving it down. If you're in the lower respiratory tract, then you're moving it up. In the oropharynx and the laryngopharynx, that's the parts of the pharynx that are shared between the respiratory tract and the digestive tract, you're going to have a stratified squamous epithelium. So the pharynx is divided into three regions. The region above the soft palate is the nasopharynx, ciliated epithelium. The oropharynx is basically behind the mouth, so it's that part below the soft palate but above the epiglottis. And below the epiglottis you have the very small region called the laryngopharynx. Moving into the larynx consists of several pieces of cartilage, along with muscle and membranes, and it contains the vocal cords. The opening between the vocal cords is called the glottis. The muscle of the larynx can stretch the vocal cords because they're made of elastic connective tissue, and that's how you change the frequency of sound when you're speaking or singing. The epiglottis is a piece of elastic cartilage that folds down when you swallow, and the anterior large cartilage that protects the delicate workings inside is called the thyroid cartilage. Below the larynx is the trachea. It looks striped in appearance because it alternates between cartilage and membrane. The cartilage rings are open across the back. They're connected, the ends are connected by a short band of smooth muscle so that you can constrict the trachea some and so that it can relax to allow the esophagus to expand when you swallow. At the end of the trachea is a point called the carina, and at the carina you have a lot of little sensory nerve endings there so that if anything solid or even liquid is inhaled so deeply that it touches the carina, it can cause a fit of coughing. It's just to help protect the lungs. And if you inhale something into the lungs, since the right primary bronchus is wider than the left and straighter, more vertical, things tend to lodge on the right side. So the bronchi branch by forking into two. So each primary bronchus branches into two. On the right side, since you have three primary bronchi, because you have three lobes, you have one fork, and then the next fork branches again. And they continue to branch in this way to supply smaller and smaller and smaller segments of each lungs. Each one of these branches has a name. We just don't make you learn all those names. You do need to know the difference between a bronchus and a bronchiole. Bronchi have plates of cartilage. This keeps them open. They do have smooth muscle in their wall that allows bronchoconstriction and bronchodilation. Constriction is a parasympathetic effect. Dilation is a sympathetic effect. And when the cartilage disappears in the smaller and smaller branches, these are the bronchioles. And without the cartilage to prop them open, the smooth muscle in the wall can cause them to completely constrict shut. Especially if there's any inflammation or mucus accumulation, you can actually totally block off the bronchioles. This is what happens in asthma and chronic bronchitis to some extent. Okay, as we get to the terminal bronchioles, that's the end of the conduction zone, and the beginning of what we call the respiratory zone is with the respiratory bronchioles, which are the branches off the terminal bronchioles. When you get into the smallest of the bronchioles, they're no longer ciliated, and the epithelium becomes thinner and thinner. When you get to the alveoli, then you are at the thinnest epithelium, a simple squamous epithelium, and that's where gas exchange can occur. When you get to the respiratory zone, you're at the respiratory bronchiole, which is the opening into an alveolar sac. An alveolar sac is a collection of alveoli. Think of each alveolus as being like a single grape, and the alveolar sac as being a cluster of grapes. The main channel through the alveolar sac is called the alveolar duct, and it opens into each individual alveolus. The alveoli also interconnect. Between them they have small pores so that gases can easily diffuse, not only between the duct and the alveolus, but from one alveolus to the neighboring alveolus. So at this point, diffusion alone along concentration gradients is going to determine the movement of gases, not conduction, not pulmonary ventilation. Okay, we're going to focus on each alveolus. Its wall is made mostly of simple squamous epithelium, and each alveolus has its own network of capillaries, which are alternately called pulmonary or alveolar capillaries. You can use either term interchangeably. And the capillaries are kind of stuck to the surface of the outer surface of each alveolus so that they are a tight connection. Additionally, the outer surface of each alveolus has a band of elastic fibers. Alveoli do expand when you inhale and recoil when you exhale, but that helps change the pressures in each alveolus, but there's really not a wholesale movement of gas, of air in and out. There are also two other types of cells found in the wall of alveoli. The second type is one that adds surfactant. Surfactant is what you add to the alveolar fluid to keep the alveoli from collapsing. The third type of cells is the macrophage, and it's called an alveolar macrophage, so that any particulate matter that didn't get removed by the mucus and the cilia as you inhale the air in and makes it all the way to the alveoli will get individually eaten by these macrophages. If the macrophages get irritated, you know from the immune system study that they can go off and try to activate the immune system. And if they re-enter the loose connective tissue to trigger an immune reaction and just die there, then whatever they ate stays there. So if stuff accumulates over a long period of time, then particularly soot particles like in smokers' lungs, then you're going to have black lungs. Macrophages that don't re-enter the living tissue can actually hitch a ride up and out through the cilia and the mucus. Lungs are lightweight, air-filled, and elastic, and they are compliant. And that's a word you need to know what it means. Compliant means that if you add even just a little bit of pressure to it, it's going to inflate more. It's very easy to inflate. That's what compliant means. Veins are also very compliant. The covering of each lung is a serous membrane. And you should have learned this in A&P 1. The serous membranes include the visceral and parietal, pleura, peritoneum, and pericardium. And in this case, the pleura is the membrane we're looking at. So the visceral pleura is the outer surface of the lungs, and it's going to come in close contact with the parietal pleura, which lines the rib cage and covers the upper surface of the diaphragm. The space between the visceral and parietal pleura is called the pleural cavity. It contains a very thin film of fluid called the pleural fluid. In humans, the right pleural cavity is separate from the left pleural cavity, so that if you collapse one lung, it doesn't affect the other lung. That's not necessarily true in all other animals. The pleural fluid has a negative pressure, so that it's always kind of sucking out on the lungs. If anything happens to disturb the negative pressure of the pleural cavity, the lung will collapse. If air gets into that cavity, it's called pneumothorax. If blood gets into the pleural cavity, that's called hemothorax. That's the end of our discussion of the anatomy and histology of the respiratory tract.